Okay. Try this problem. It is given to you that 100 grams of water at 10 degrees C is mixed with 250 grams of ice, which is initially at minus 10 degrees C. Okay, so water and ice are put together. So, see, one is at 10 degrees, the other is at minus 10 degrees. Some heat exchange will happen, temperature changes will happen, state changes also may happen. Okay, so the aim is to find out finally what will be there in the mixture. You will assume this is an isolated system, so no heat exchange with the surroundings. Ice and water will exchange heat among themselves, that's all. So finally, how much ice will be there, how much water will be there, and at what temperature they will be there. Okay, that is what you have to find out. You can use these values. Specific heat of ice is 0.5 calorie per gram per Celsius degree. Specific heat of water is 1 calorie per gram per Celsius degree. And latent heat of fusion, okay, for ice water conversion is 80 calories per gram. Okay. Try this problem. I'll give you 3 minutes. Right. Since I did not get any answer from you all, I want you to solve another problem before you solve this. L- Let me show you how you can relate them also. Like after you solve this, I'll show you how it can be related. Try this question, both of you. You may have seen this question earlier on my WhatsApp status also. Never mind. So read the question carefully and solve. So as you can see, there are two ants here. You can call them as A and B. So basically, they start walking along this path. If the ants start simultaneously and walk at the indicated speeds, now they have a particular speed of walking in grass, particular speed of walking in sand, gravel, and all. And in between, these cookies are given. Whenever the ant reaches there, it spends that much time eating those cookies, you can imagine. Okay. And then it moves forward. Fine. So, where exactly would they meet and at what time is what you need to find out. Okay. Try this. Okay, I got one answer as 110 steps from the grass end. It'll be better if you can give the time also. And I got one more answer as they will meet in gravel. Where exactly? Okay, at what exact distance will they meet is what I want. Like how many steps from the upper end or the lower end and at what time? Okay, try to be more specific. Fine. I got another answer as they will meet at 75 seconds at 110 steps from the grass end. Okay, 110 steps from the grass end means 100 steps there is grass itself. So according to that answer, they'll be meeting somewhere here. 100 steps in grass plus another 10 steps in gravel with for that ant A and for ant B the remaining distance. Okay, and 75 seconds is one answer that I got. Okay, one more minute. Others also send me the answers. Okay, those of you who uh, fine, whether you have an answer or not, the approach is what makes this question relevant to calorimetry. Okay. Uh, Vanilla, tell me, how did you approach this question? Like, how did you try to solve this? Step by step, I want. Distances are given, speeds are given, and the time for which they wait in between is also given. Okay. So, how to proceed?
So time taken by the red ant equal to time taken by the black ant, sir.
Okay, yeah. Wherever they meet, the time for which that ant moves is same as the time for which this ant moves. Correct. Next.
So then I assume the time taken by the red ant is x and the time taken by the black ant is 40 minus x.
Time, why
And
will
I
it be x and 40
equated.
minutes? Times will be equal. No?
So not the time, like the time taken when they travel in the gravel.
No, why did you directly go to gravel? Step by step, I want. None of them is starting in gravel, no?
Sir, we know how much time they will take on grass and on
Okay, yeah,
sand, but we
yeah,
don't
that is
know
what I
on
was,
gravel.
I mean, that is what I want from you step by step. So first you found out how much time this ant will take to reach here, right? The red ant will take to cover the grass. That's what you tried for, you found out first, isn't it?
Yes, sir.
Okay, so see, in grass the distance is 100 steps and the ant moves at 2 steps per second. So obviously it takes 50 seconds to cover that. Now, notice this, all of you. We don't know if that red ant will actually cover that distance or not. Okay, by the time the red ant completes moving through grass, the black one may catch up with it somewhere here also. We still haven't checked that. We are going step by step, but this is how we take the steps. Okay, we will assume the red ant completes the movement through grass and find out how much time it takes for that. That is 50 seconds. Okay, Venla, what did you do next?
So then I assume the time taken by the red ant on the gravel as X.
Okay, so you are continuing only from one side, but this one will, like, what is the guarantee that it will step into gravel? Why did you go to that step? Okay, let's say you assumed that that happens. Fine. So 50 seconds here, then 20 seconds eating these cookies, and then you assumed it moves through gravel also for some time X. Okay. After that,
So black ant moves on sand and 40 minus X time on gravel.
why 40 minus X? I didn't understand. Okay, total time taken on gravel you found out as 40. So you gave, no, no. Okay, wait, I'll come to that. Okay, so you are saying through sand, the black, assume the black one completes moving through sand. Sand extends up to 120 steps and 4 steps per second. This takes 30 seconds. Okay, then you assumed it steps into gravel. Okay, so it is eating of these cookies also you assumed, for which there's no guarantee. Okay, and then you assumed it moves through gravel, and by the time they meet, it travels for 40 minus X seconds. Why?
So the total time is 40, so 40 minutes.
No, total time is 40. Okay. Mm, distance we can split. If one ant travels some X distance, the other ant has to travel the remaining distance. But if one ant travels for some time, the other ant has to travel for the remaining time. What is, I mean, that logic I'm not understanding. Just a moment, is that valid or not? Let me think. No, that does not really make sense. No, suppose there are two persons moving along this path, one starting from here, one starting from here. Let's say they travel with some speed. There's only one kind of path. Now, if they are going to meet somewhere here, traveled for remaining time 100 minus t or something like that, no, both of them would have traveled for the same time, or it depends on when they started moving, isn't it? The time at which the red ant enters gravel need not be the same as the time at which the black ant enters into gravel. So that logic I don't think is correct. Okay, anyway, partially your approach is fine. You first assume the red one completes that grass patch, the black one completes that sand patch, and then you try to do something. Fine. Sohan, how are you trying to solve this? Let me erase all this first. Okay, you can start explaining. How did you try to solve this?
Sir, we know that after the red ant reaches the cookie, it will already be 50 seconds.
Okay, so you assumed that this part will be completed.
Yes.
We don't know if it will be completed, but you assume this will be completed
Then
and
we
it
can
takes 50 seconds.
check where
Okay.
the black ant will be.
In 50 seconds, you want to check where it will be.
Yes, sir.
Okay, that is also another approach that you can take. And yeah, where will the black ant be in 50 seconds?
Sir, in the near the cookie, it would be after the completion of 30 seconds, sir.
Okay, so yeah, you're going step by step here also. You first found out the time it takes to move through sand. That takes 30 seconds, 10 seconds.
So total would be 40 seconds.
So notice this, all of you. He assumed one step to be completed on that side. One step means not one walking step, one stage to be completed there. Okay. The red ant moving through grass, he first considered the time that would take. 50 seconds. In 50 seconds, he's finding out what all the black ant can do. Now, some of you may have started the other way also. You may have first started with the black ant. For it to complete the first stage, it takes 30 seconds. In 30 seconds, you can check where the red ant will be. That way also it can be solved. He found out for the red ant first. Now he's seeing what the black ant would do in that much time. And see, the first stage on the upper side takes 50 seconds. First stage on the lower side takes 30 seconds only. So that 50 seconds we will keep on one side. The other side we'll see what all will happen in 50 seconds. Okay. So the first stage on the upper side, okay, the red ant side takes longer. Okay. So we'll keep that aside and see what all can happen with the black ant. Okay. So 30 seconds moving through sand is done. 10 seconds eating cookies is done. So on, continue.
So then the black ant would enter the gravel first.
Okay. It will enter and then
Uh, let's assume after the completion of 50 seconds, the red ant would eat the cookies for 20 seconds.
uh, okay. You said that the black ant enters gravel, and then you are considering what happens with the red ant.
That
Hmm.
means on the other side, it would be a total of 70 seconds.
But here, like on the black ant side, 30 seconds we have explained what it does. 10 seconds it explained what it does. Here there is up to 50 seconds. No, the red ant to cross the grass itself, it takes 50 seconds. Then it would have been better if you had seen what all the black ant can do in 50 seconds. No.
Yes, sir.
Okay. Anyway, you can say that it will not be able to complete this gravel path
Yes, sir.
in another 10 seconds. Okay. That also you would have checked. Maybe you didn't say, but definitely you have to check. So yeah, in gravel, the distance is 80 steps and the ants move at 2 steps per second. So 30 seconds, 10 seconds for the black ant, 40 seconds is over by the time it completes eating that single cookie. Another 10 seconds, it moves through gravel and it will be somewhere here. It will not complete that gravel patch. Okay. So by the end of 50 seconds, the black ant would reach somewhere here. The red ant has just reached this cookie plate. Okay. Okay. Now you are seeing what the red ant would do. Fine. So you are assuming it will eat off those cookies. I mean, you are assuming it will complete that stage. Okay. The second stage for the red ant is eating those cookies. Okay. That takes 20 seconds. You assumed that it completes that stage. We have no guarantee yet. Okay. Because another 20 seconds, the black ant may catch up with it and it may also start eating those cookies. That process is also possible. I mean, that chance is also there, but you assumed it completes this. Okay. Go ahead.
Sir, now we will check. After the red cookie eats the red ant
Uh,
eats the cookie, it would be 70 seconds, right?
Okay, assuming the red ant only eats those cookies,
Yes.
it takes 70 seconds. You are assuming that stage to be completed. Okay.
Then we will find out where the black ant would be after
By 70 seconds, where the black ant would have reached, you have to find out. Okay. See, by 50 seconds, it has reached that black line that I have drawn. We give it another 20 seconds now. Okay. In gravel, it moves at a speed of 2 steps per second. No. So in 10 seconds, it would have moved 5 steps. Wait, 2 steps per second. No. So in 10 seconds, it would have moved 20 steps. So 20 steps are done here by the black ant. In another 20 seconds, it will cover another 40 steps. 20 plus 40 is still 60. So it will still be moving through gravel itself. Okay. So by 70 seconds, the black ant would reach somewhere here. 20 steps plus another 40 steps. Fine. The red ant would have just finished eating those cookies. Just a moment. So by this time, by 70 seconds, they have reached a common stage, I can say. Okay, we can say. The red ant has finished eating cookies. Now it will step into gravel. The black ant is already in gravel. So they are going through a common stage now. Okay. So it's like the red ant is starting from here. The black ant is starting from here. 20, 40 done. Another 20 steps are left through gravel. Okay. Red ant will be moving from one side. Black ant will be moving from the other side. How many steps are left? 20 steps. They both move with a common speed. So they will meet exactly in between. They will meet here. Okay. So 20 steps were left. No, so 10 steps on this side, 10 steps on this side. Okay, 10 steps the black one will cover, 10 steps the red one will cover. That is what they are going to meet. So you can say that where will they meet? 100 in grass. The red ant has traveled 100 in grass. another 10 in gravel. So red ant takes 110 steps. The black ant, it has covered 120 here, then 20, 40, 10. 20, 40, 10 is 70, 70, 120, 190. So red ant covers 110 steps, black ant covers 190 steps. You can tell the time also at which they meet. Okay, good. So observe how you solve this problem. You, like, unknowingly itself, okay, intuitively you did this. You divided it into stages. Okay, and you assumed they complete stages one by one from this side, one from this side, and you found out where they are going to meet. You have to do something similar with this problem also. Okay, Pawan has just joined, so let us show this problem to him. So on one hand, we have 100 grams of water at 10 degrees C. On the other hand, we have 250 grams of ice at minus 10 degrees C. Okay. Now ice and water will exchange heat and temperature changes will happen. There is a possibility of state change also. Okay. So how is this relevant? Now you have to go step by step here also. 100 grams of water at 10 degrees. No, it will lose heat. It is at higher temperature. It will lose heat. When water at 10 degrees loses heat, its temperature will decrease first. State change won't happen. It won't convert into ice immediately. Its temperature will decrease. So if you look at the stages here, 100 grams of water at 10 degrees, the first stage that it goes through is the temperature change stage. So you will assume water goes down to 0 degrees. Okay. It's like assuming the red ant completing that grass patch. Okay. We don't know if that will actually happen or not, but we have to assume, we have to take it stage by stage. So let me, okay, we can just draw a line here. On one hand, we have water at 10 degrees C. On the other hand, we have ice at minus 10 degrees C. Okay, quantities are also given, 100 grams, 250 grams, that's fine. Okay. We know there are specific heats, latent heat of fusion and all. In between, there is that stage of state conversion also that can happen. Okay. Stage will complete. Where they are going to finally meet is what we need to find out. This is how that ant question is relevant to this calorimetry question. So when will state change happen between ice and water at 0 degrees C? Okay, so if they ever meet, they have to meet at that temperature only. Means if ice and water ever coexist, they have to coexist at that temperature. Okay, so now we can split this into stages. 100 grams of water at 10 degrees C, you will first assume it completely converts to water at 0 degrees C. Okay, on the left hand side here, there will be water at 0 degrees C. On the right hand side here, there will be ice at 0 degrees C. So 100 grams of water at 10 degrees, if it goes down to 0 degrees, okay, temperature change is happening. You will use the equation delta Q is equal to ms delta T to find out how much heat is released in this process. This heat will be used by ice to undergo conversion on the other side. Okay, so we'll assume this stage completes. We don't know if it will complete or not. Let's assume it completes. Okay, like how you assume the red ant moves through the patch of grass. So if you do this, mass of ice here is 100. Sorry, mass of water here is 100. 100 only, no? Yeah. Specific heat of water is 1 calorie per gram per Celsius degree. The temperature change from 10, it has to go down to 0. So temperature change is 10. Actually, I'm writing heat lost, okay, not heat gained. So it is ready to give 1000 calories of heat. We don't know if this stage will complete or not, but if it completes, 1000 calories will be released. Okay. Now we will see one stage on the other side, like how you consider the motion of the black ant. Okay, red ant one patch, one stage takes 50 seconds. What does the black ant do in that time is what you found out next. Okay, so you, like, intuitively you calculated how much time it would take to move through the sand. You assumed that stage will be completed. Okay, we'll do the same here also. So suppose ice at minus 10 degrees converts completely to ice at 0 degrees. Okay, let's assume that stage completes. Then that the heat T grams, specific heat of ice is 0.5 calorie per gram per Celsius degree. Minus 10 to 0 is a change of 10 units. So 10 into 0.5 is 5, 5 into 250, 1250. This stage, for this stage to complete, it requires 1250 calories. Now this, there is a relation, I mean, these two are exchanging heat, ice and water are exchanging heat. So for the ice to convert, or for the temperature of ice to increase, water's temperature has to decrease, and this heat has to go to that side. Now, water, by the time it comes to 0 degrees, it will only be able to release 1000 calories. Okay. But ice to come to 0 degrees requires 1250 calories. Now, assume both of them start at the same time. No, the moment water starts releasing heat, ice starts absorbing heat. Okay, so both processes start at the same time. Now, you all tell me which of these stages will definitely complete. Water coming to 0 degrees will definitely complete, or ice coming to 0 degrees will definitely complete. Which process will complete for sure as they keep exchanging heat? Okay, I got two answers. Water coming to 0 degrees will complete. Yes. Okay. See, water will be releasing heat, ice will be absorbing heat. But as water releases 1000 calories, it comes off to zero. By the time ice gets 1000 calories, it will not have come to zero yet. Okay, because ice requires 1250 calories of heat to come to zero. Okay. So this stage is going to complete. Okay. It's like in this ant question. You first found out how much time the red ant takes to move through grass, 50 seconds. Then you saw what the black ant does. To move through sand, it takes 30 seconds itself. So by the time the red ant moves through grass, 50 seconds, black ant moving through sand would have completed. Then you went to the next step on this side. Okay, the first step on the upper side is still not complete. First stage, okay, I should not use the word step. First stage on the upper side is still not complete. First stage on the lower side was complete, and you went to the second step on the lower side to see how much time it takes. Okay, you have to do the same here also. The water coming to 0 degrees will definitely complete. Now, by the time water comes to 0 degrees, it would have released 1000 calories. So, ice would have completed some of this stage. Not complete, it would not have come to zero, but it would have come to some temperature between minus 10 and zero. Okay, some temperature increase would have happened because it got 1000 calories of heat. In fact, you can tell how much also. Uh, See, 1000, 1250, the ratio is 4 is to 5. Okay. So water is giving 4x amount of heat. For that stage of ice to complete, it requires 5x. But out of 5, it is getting only 4. Means out of 1250 calories, it got only 1000 calories. Right? So only 4/5 of that stage will be completed. 4/5 of that stage means what? What is the stage here? Minus 10 to 0. Minus 10 to 0. 4/5 of this will be completed. If you divide this into 5 parts, each part will be 2 degrees change, minus 10 to minus 8, minus 8 to minus 6, minus 6 to minus 4, minus 2, and then 0. 4 out of 5 parts will be completed. Means it would have come to minus 2 degrees C now. Okay. 10 to 8, 6, 4, 2. 4 steps are completed. 2 to 0 will not be completed. Okay. You can even tell that. By the time water comes to zero, ice would have come to minus 2 degrees. Okay. There is still some temperature difference. Water is now at zero. That stage is complete. Ice is only at minus 2 degrees. So there is still some temperature difference. Some more heat exchange will happen. As long as there is a temperature difference, heat exchange will keep on happening. Okay. So we have to go to the next stage for water because the first stage for water is completed. What is the next stage for water? Water at 0 degrees converting to ice at 0 degrees. That is the second stage for water. Okay. Now for water at zero, to convert to ice at zero, state change is happening. Now you have to use the equation delta Q is equal to ml. Okay. So let's go to the second step on this side. First stage is completed. Second stage for water, the heat that it can lose. Okay. We don't know if it will definitely lose that heat or not, but the delta Q that it latent heat for ice water conversion is 80 calorie per gram. So 100 into 80, it is ready to give. I mean, it will give 8000 calories of heat if it completes that stage. Okay. But this is like a waiting stage. At 0 degrees, water waits to convert to ice. Okay. So it's like waiting near those cookies. To finish eating those cookies, the ant has to wait. Whichever ant reaches the cookies first, it will have to wait there to finish eating. The other ant will be moving. Okay. So something similar here. Water waits at 0 degrees as it is converting to ice. If water completely converts to ice, it would release 8000 calories. Okay. Now see, completing this step releases 8000 calories. Fine. Now ice was at minus 2 degrees. That ice coming to 0 degrees was not complete. How much of it was complete? 1000 calories it got. 250 more are required. Now, water can give those 250 calories. It is ready to give 8,000 calories, no, by the time it converts to ice. Okay, so as long as there is a temperature difference, as long as water keeps converting to ice, it can give up to 8,000 calories. Out of these 8,000, 250 will be taken by ice first. Okay, so ice now comes to 0 degrees. Now, this 8,000 calories will not be transferred to ice completely, because you have to see heat transfer will happen only as long as there is a temperature difference, no? So you have to see whether there is a temperature difference being maintained or not. So as water converts to ice, it will keep releasing heat. Ice will keep taking that heat. Now, how much extra heat does ice need to come to 0 degrees? Only 250 calories more it needs. That will be taken by it. Okay. So water in the first stage gave 1,000 calories to ice, which the ice took. As water is going through the second stage, okay, now you have to enlarge the second stage and observe it in detail. So water is going through this second stage of converting to ice. So visualize it like this. There is water at 0 degrees C. It's ice at 0 degrees C. On the other hand, as water entered into this stage, the actual ice that was there was here. How much? 250-gram ice that was there is at minus 2 degrees C. Okay, it has not reached 0 yet. Okay. This water that is there, 100-gram water, at 0 degrees, it has started this stage of converting into ice, a stage where conversion of state happens or change of state happens. Okay. As water is going through change of state, when it partially finishes that stage, means when some water undergoes change of state, not all water converting to ice. All water converting to ice would release 8,000 calories. But let's say some water has converted to ice and you assume it has released 250 calories. The ice, on the other hand, will take those 250 calories. Now, water is going through that stage where it is at 0 degrees. Ice has received some more heat and ice also has come to 0 degrees. No further heat exchange will happen. Okay, because there's no temperature difference. Water was at 0 degrees, some of it melted into ice. Not completely, some of it melted into ice, which is at 0 degrees itself. On the other hand, the original ice that was there has come to 0 degrees. That's all. Now, why will any further heat exchange happen? When there's no temperature difference, there won't be heat exchange and the process stops. Okay, so finally, what you will see here is water at this stage. Means some water converting to ice, not all water. So out of the 100 grams of water that was there, some would have converted to ice. On the other hand, all the 250 grams of ice that is there will remain as ice at 0 degrees. Okay. Now we have found out the final temperature. Finally, the system will be at 0 degrees. That we have concluded. Now we know that some water would have converted to ice, frozen into ice. How much water would have frozen into ice? We need to find out. Now, for all the water to freeze, means for 100 grams of water to freeze, it has to release 8,000 calories. But by the time their temperatures became equal, how much heat did the water actually release? 250 calories only, because that much was enough for ice to come to 0. Okay. So, how much water freezes when it releases only 250 calories out of 8,000 is what you need to find out. You can use ratios and proportions. 8,000. So, remove the zeros, that's all. One more zero also can be removed. So you get x is equal to 25 by 8, which is 3.1 by 8 is how much? 0.125. So 125 grams. So 3.125 grams of water would have converted to ice. How much water was there initially? 100 grams was there. 3.125 converts to ice. How much remains as water? 96 point, how much will that be? 875 grams stays as water. And along with that, see this 3.125 converted to ice, and the original 250 grams of ice is there as it is. So finally, 253.125 grams of ice will be there. And both of them will be at a common temperature of 0 degrees C. This is the final state and final composition of the mixture. Is this clear to all of you? Did you understand how you have to go stage by stage and see which one completes the first stage first, then how much of the second stage will be completed that way? Okay, you can think over it once again. In fact, this AND problem is slightly more complicated, and this you can use to solve questions like this also. On one hand, you can have ice at some temperature. On the other hand, you can have steam. Okay. In between, ice water conversion can happen. Another so possible. Okay. So you can be given questions like this also. This will be slightly lengthier. Then stage by stage, ice going to 0 degrees first, then ice converting to water, then water temperature increasing, water converting to steam, steam temperature increasing. If you look from one side, it look like that. Then from this side, if you see steam converting to water, okay, at 100 degrees, it going down to water at zero, water at zero going to or changing to ice at zero, then ice at zero going to even further lower temperature. Somewhere in between, these two will attain a common temperature, and there the process will stop. Okay. So if you think of it this way, you'll be able to solve such problems. Okay. Let me give you one more problem like this. Try to solve it. First, tell me, do you have any doubts? Okay, try this now. 20 grams of ice at minus 20 degrees C is mixed with 10 grams of water, which is initially at 50 degrees C. Okay, let me give you these values. Specific heat of water is 1 calorie per gram per Celsius degree. Water conversion latent heat is 80 calorie per gram. Find out the final composition of the mixture. Okay, or system. Try this, all of you. I'll give you 3 minutes. Okay, I got two different answers. Both saying 0 degrees, but one saying 13.75 grams of water, 16.25 grams of ice. Okay, that makes 30 grams. Another answer is 21.875 ice and 8.125 water. Okay. Pawan, any answer? Fine, let's use the same approach. Ice conversion, sorry, water conversion, ice conversion. In between, there is a state change also possible. Just a moment. Okay. So 10 grams of water at 50 degrees C. It starts from here. On the other hand, 20 grams of ice at minus 20 degrees C. Okay. So this is a common temperature of 0. On this side, this is in water stage. This side is ice stage. Okay, we'll see who will reach there first and all. Fine. So stage by stage, if we go 10 gram water at 50 going down to 0, if you use delta Q is equal to ms delta T, this can release how much heat? M. Specific heat for water is 1 heat. Okay. First stage, on the other hand, 20 grams of ice. From minus 20, we'll assume it goes to 0. Okay, we'll assume it completes the stage. We don't know if it does that or not. So how much heat is required? ms delta T again, 20. Specific heat for ice is 0.5. Temperature 5, 200 calories. Only 200 calories is needed. So whichever requires less will complete first. So this stage will be completed. So ice coming to 0 will definitely happen. We don't know if water will come to 0 or not. So water was releasing heat, ice was taking heat. Ice has come down to 0. By that time, water would not have come to 0, because for water to come to 0, it has to release 500 calories, out of which it has released only 200 calories. Okay. So only 2 out of 5 parts is done. Only 2/5 of that stage is done. So it's like water has reached somewhere here. 2 parts here out of 5 parts. So 2:3 ratio, we are splitting. Okay. So from 50, it didn't go down to 0. 50, if you split into 5 parts, each part is 10. So 2 parts completed means 40, 30. It would have come to 30 degrees. That much we can say. By the time ice comes to 0, water has only come to 30 degrees. Okay. Now we will look for the second stage on that side. Second stage on that side is ice at 0 converting to water at 0. There is 20 grams of ice. If ice at 0 has to convert to water at 0, then the heat that it requires is how much? ml. 20 into latent heat here is 80. It would require 1600 calories. Okay. But will the water be able to provide that much? No. Out of 500 that it will be able to release, it has already released 200. The first stage on the right side is completed. No. So this part on the left side is also completed. So it has released 200 calories. How many more can it release? 300 calories. So this stage will complete now. Okay. So water will definitely go down to 0 degrees. So now this 2:3 and all won't matter. So water will release all the 500 calories and it will go down to 0 degrees. Now ice had reached 0. Ice had reached 0, and it has started converting to water also. Ice has started melting. For ice which is on that side, 20 grams, to completely melt, it requires 1600 calories. Okay. But see, water had already given 200 calories. How much more can it give? 300 only. So out of these 1600, ice can only get 300 calories out of 1600 that it requires. So ice won't completely melt into water, only partially it will melt. How much part will melt? 300 out of 1600 means 3 out of 16 parts will melt. That's all. So ice won't completely go to water. Only 3 out of 16 parts will melt into water. And ice is already at zero. When it melts to water, also it will be at zero only. On this hand, water has come to zero. That's all. Then the heat exchange will stop. Okay. So water, all the 10 grams of water, okay, 10 gram water will come to 0 degrees. And on the other hand, what you will have is 3 out of 16 parts of ice, means 3 by 16th of 20 grams will be converted to water. So this will be in water stage. Okay, just a minute. Let me write it properly. 3/16th of 20 grams would have converted to water at 0 degrees. The remaining means how much? 13 out of 16 parts at 0 degrees. This is what you will have finally. Okay, so finally, how much water will be there? All this is water. 10 plus, okay, 5s, 4s, 3 5s, 15. 15 by 4 is how much? 3.25. 15 by, no, 3.75. So 13.75 grams of water at 0 degrees C. And this is ice. So 3.75 gone out of 20. If you remove 3.75, 16.25 at 0 degrees C. This is what you will finally find. Okay, so good. So hope you're getting a hang of how to solve such problems. You'll find such problems in any standard reference book that you take. Okay, you can create problems on your own also. What is there in there? Take some ice at some temperature, water at some temperature, assume they are put together, or take ice at some temperature and steam at some temperature, some amount of steam, put together, find out what common temperature they will attain. Okay. So questions like these are the slightly difficult questions in calorimetry. But they can be solved. You have to be very careful with the calculation. Last class, we solved one problem, the last one that we solved. Just a moment. Yeah, what you were asked to find out is, like, you were given ice at a particular temperature and you were asked how much water is to be mixed to bring it to a certain final stage. So the final stage was known to you. The mass, on the other hand, was unknown. Those are level 1 questions. Okay, what we did today is level 2, level 3 types. Okay, so practice some problems like this, then it will become easy. Fine, we'll stop it here for today. Next class, which will be day after tomorrow. Tomorrow I'll not be taking. Day after tomorrow I'll take. And in that class, we'll discuss something called calorimeter. Okay, there is a device called calorimeter. Simple idea only. It won't take much long. And after that, we'll start talking about heat transfer. Okay, there are different modes of heat transfer from one point to another. Conduction, convection, radiation. We'll start talking about, or we'll start discussing conduction and solve problems based on it. Okay, right. Thank you all. From next class onwards, try to join on time.